we are advised to wear white clothes during summer. Calorimetry. We study about the effects of heat energy. When heat energy is supplied to substances, physical changes takes place in them. Solid form of water, that is ice, is changed to liquid form, and liquid form of water is changed to gaseous form. These are all the physical changes due to heat energy. Similarly, heat energy produces chemical changes also. To know more about the physical and chemical changes that takes place in substances, we need to measure the amount of heat involved. The technique used to measure the amount of heat involved in a physical or a chemical process is known as calorimetry. Temperature. Temperature is a physical quantity which expresses whether an object is hot or cold. It is measured with the help of thermometer. There are three scales to measure the temperature. They are Celsius scale, Fahrenheit scale, and Kelvin scale. Among these three scales, Kelvin scale is the most commonly used one, and you will study about this in detail in Standard 9. Unit of heat. We know that heat is a form of energy. The unit of energy in SI system is joule. So heat is also measured in joule. It is expressed by the symbol capital J. The most commonly used unit of heat is calorie. 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. The relation between calorie and joule is given as 1 calorie is equals to 4.186 joule. Do you know the amount of energy in food items is measured by the unit kilocalorie? 1 kilocalorie is equals to 4200 joule approximately. Next, we are going to understand the heat capacity by a simple activity. We are going to take some amount of water and cooking oil in two separate vessels and heat them till they reach a particular temperature. What will happen now? Which one is heated first? Water will take more time to get heated. Why? In general, the amount of heat energy gained or lost by a substance is determined by three factors. They are mass of the substance, change in temperature of the substance, and nature of the material of the substance. Different substances require different amount of heat energy to reach a particular temperature. This nature is known as heat capacity of a substance. Here, the heat capacity of oil is lower than the heat capacity of water. So how to define heat capacity? Heat capacity is defined as the amount of heat energy required by a substance to raise its temperature by 1 degree Celsius or 1 Kelvin. It is denoted by the symbol C. So heat capacity is equals to amount of heat energy required denoted by the letter Q divided by rise in temperature is denoted by delta T. Therefore, heat capacity C is equals to Q by delta T. The unit of heat capacity is calorie per degree Celsius. In SI system, it is measured in joule per Kelvin. Let's see some problems. Problem 1. The temperature of a metal ball is 30 degrees Celsius. When an energy of 3000 joule is supplied, its temperature raises by 40 degrees Celsius. Calculate its heat capacity. So what's the formula to find out the heat capacity? It is C is equals to Q by delta T. So what is Q here? It is 3000 joule. The energy required to raise the temperature of the metal ball. Next, what is delta T? The rise in temperature. How the temperature is raised? From 30 degrees Celsius to 40 degrees Celsius. So what is the difference? 40 minus 30 we are getting 10 degrees Celsius or 10 Kelvin. So C is equals to 3000 by 10 we are getting 300 joule per Kelvin. So the heat capacity of the metal ball is 300 joule per Kelvin. Next, problem 2. The energy required to raise the temperature of an iron ball by 1 Kelvin is 500 joule per Kelvin. Calculate the amount of energy required to raise its temperature by 20 Kelvin. So it's simple. So 500 into 20, we are getting 10,000 joule. So now enter into the formula. C is equals to Q by delta T. So here what we need, the Q value, the energy required. So Q is equals to C into delta T. So what is C here? The heat capacity of the iron ball. What is it? It is 500 joule per Kelvin. And what is the delta T? The temperature? 20 Kelvin. Okay. So Q is equals to 500 into 20. It is 10,000 joule. So the amount of heat energy required is 10,000 joule. Specific heat capacity. When the heat capacity of a substance is expressed for unit mass, it is called specific heat capacity. Specific heat capacity of a substance is defined as the amount of heat energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius or 1 Kelvin, and it is denoted by the symbol C. Specific heat capacity is equals to amount of heat energy required, that is denoted by the letter Q, by mass, that is denoted by M, into raise in temperature, that is denoted by delta T. Therefore, C is equals to Q by M into delta T. The SI unit of specific heat capacity is joule per kilogram per Kelvin. Students, for both heat capacity and specific heat capacity, we are using the symbol C. To differentiate the heat capacity from the specific heat capacity, for heat capacity we used C dash, for specific heat capacity we are using C. Let's see some problems related to specific heat capacity. Problem 1. An energy of 84,000 joule is required to raise the temperature of 2 kg of water from 60 degrees Celsius to 70 degrees Celsius. Calculate the specific heat capacity of water. So what is specific heat capacity? C is equals to Q by M into delta T. So here Q is 84,000 joule. Then what is M? The mass of the water is 2 kg. Next, the delta T, that is change in temperature, is changed from 60 degrees Celsius to 70 degrees Celsius. So 70 minus 60, we are getting 10 degrees Celsius or 10 Kelvin. So C is equals to 84,000 divided by 2 into 10, that is 20. So we are getting 4,200 joule per kilogram per Kelvin. So the specific heat capacity of water is 4,200 joule per kilogram per Kelvin. Next, the problem 2. The specific heat capacity of a metal is 160 joule per kilogram per Kelvin. Calculate the amount of heat energy required to raise the temperature of 500 gram of metal from 120 degrees Celsius to 325 degrees Celsius. Okay, so here what we need, the energy required, the heat energy required to raise the temperature of 500 gram of metal. So specific heat capacity is equals to C is equals to Q by M into delta T. Here we need Q, so take the Q out. Q is equals to C into M into delta T. So what is C here? The specific heat capacity of the metal, it is 160 joule per kilogram per Kelvin. What is the mass? It is 500 gram. So we have to convert that gram into kilogram. For that, simply we should divide that by 1000. So 500 by 1000, we are getting 0.5 kilogram. So delta T is equals to 325 minus 125, we are getting 200 or 200 Kelvin. Now substitute the values in the formula. 160 into 0.5 into 200, we are getting 16,000 joule. So the amount of heat energy required is 16,000 joule. Calorimeter. A calorimeter is a device used to measure the amount of heat gained or lost by a substance. It consists of a vessel made up of metals like copper or aluminium, which are good conductors of heat and electricity. Now note the picture. The metallic vessel is kept in an insulating jacket to prevent heat loss to the environment. Then there are two holes in it. Through one hole, a thermometer is inserted to measure the temperature of the contents. A stirrer is inserted through another hole for stirring the content in the vessel. The vessel is filled with liquid which is heated by passing current through the heating element. Using this device, we can measure the heat capacity of the liquid in the container. Do you know? The world's first ice calorimeter was used in the year 1782 by Anthony Lavoisier and Pierre-Simon Laplace to determine the heat generated by various chemical changes. Thermostat. A thermostat is a device which maintains the temperature of a place or an object constant. The word thermostat is derived from two Greek words, thermo meaning heat and static meaning staying the same. So thermostats are used in any device or system that gets heated or cools down to a preset temperature. It turns an appliance or a circuit on or off when a particular temperature is reached. Devices which use thermostat including building heater, central heater in a room, air conditioner, water heater as well as kitchen equipments including oven and refrigerators. Sometimes a thermostat functions both as a sensor and the controller of a thermal system. Thermos flask or vacuum flask. The thermo flask is an insulating storage vessel that keeps its content hotter or cooler than the surrounding for a longer time. It is primarily meant to enhance the storage period of a liquid by maintaining a uniform temperature and avoiding possibilities of getting a bad taste. Let's see the working of thermo flask. See the picture. The thermo flask has double walls which are evacuated. It is silver on the inside. The vacuum between the two walls prevents heat being transferred from the inside to the outside by conduction and convection. With very little air between the walls, there is almost no transfer of heat from the inner walls to the outer wall or vice versa. Conduction can only occur at the points where the two walls meet at the top of the bottle and through an insulated support at the bottom. The silver wall reflects radiated heat back to the liquid in the bottle. Do you know? The vacuum flask was invented by Scottish scientist Sir James Dewar in 1892. In his honor, it is called Dewar flask. It's also known as Dewar bottle.